Hey everyone, in today's video, I'll be testing out 3 different LiDAR scanners. We have got the SHARE S20, the SHARE C1, and the Manifold Tech Pocket 2, which I already tested in the last week's video. Manifold Tech has disabled the accuracy setting in favor of speed, which makes no sense to me. So in this test, I will re-enable it and run the scan again. Accuracy isn't negotiable. No LiDAR scanner should ever let you stratify it just to save time. The SHARE C1 and Pocket 2 both use the same internal IMU sensor, the ICM-40609, while the SHARE S20 is equipped with a higher precision IMU, the 45686. I'm going to run all 3 LiDAR scanners under the same conditions by scanning a single large loop about 560 meters long. I will place a checkerboard marker at both the start and end points so we can see how much each scanner drifts from where it began. That way, we'll find out whether the higher precision IMU in the SHARE S20 really make a difference. After that, I will remap the point cloud on my PC to check if the scanners can fully close the loop, measure accuracy, and compare the quality of the colorized point clouds. One thing to keep in mind, in a real project, when you are scanning an area this large, it's better to walk paths that create multiple smaller loops. Each time the scanner revisits a point it's already seen, it forms a loop and uses that to correct its trajectory. The reason I'm running this test with one single large loop is to intentionally create more drift. That way, I can see if the software is capable of properly closing the loop when I remap the data. Walking across paths like this creates multiple loops, and smaller loops usually give better accuracy. If you can keep each loop within about 100 meters, the SHARE S20 can achieve accuracy error as low as 3 mm. I start with the SHARE S20. Using the checkerboard, let me place the scanner in the exact same spot and point it in the same direction, which makes the consistency tests more reliable. There is a new firmware update for the SHARE S20. Now if the GPS reception isn't strong enough, you will get a pop-up warning, and if you haven't used the scanner for a while, it may take some time to initialize the GPS until it locks onto a good signal. I'm only recording the GPS to show how RTK works with the S20. For this test, I won't be using RTK to remap the point cloud. Take a look at the PDOP value. It's pretty high, around 1.9, almost 2. If you leave the scanner running longer, that value will drop. Right now, the horizontal accuracy error, or HRMS, is about 24 mm. After about 5 minutes of scanning, the PDOP value dropped to 1.5 and the horizontal accuracy error came down to 18 mm. So if your RTK hasn't been used for a while, it's a good idea to leave it on for around 5 minutes before you start scanning. That way, you will get a better PDOP value and improve accuracy. Right now, I'm in an open area, and the best accuracy error I can get is about 14 mm. The time of the day also plays a big role in RTK accuracy. Here in Thailand, mornings usually give the best results, and late evenings are also good. The red trajectory line you see on the preview screen is calculated from the LiDAR and IMU sensors. The GPS coordinates and RTK data are only recorded and synchronized with the hardware. To actually fuse the GPS coordinates into the scan, you need to process it later on your PC using SHARE Cloud Studio. Now I'm closing the loop and you can see on the preview screen that the SHARE S20 drifts only in the horizontal plane. When I orbit the wheel, the ground level lines up perfectly. There is no noticeable drift in the vertical plane. After this step, I will move the data to my PC and remap the scan. That way we can check how effectively the software closes the loop and evaluate the accuracy. Next, let's move on to the SHARE C1. The SHARE C1 is noticeably lighter than the SHARE S20, and you can really feel the difference when holding it, especially during longer scans. In my previous video, when I tested floor-to-floor levels, the SHARE S20 showed less accuracy error compared to the SHARE C1. Let's see how the C1 performs in this test. From here, you can see that the SHARE C1 drifts both horizontally and vertically, unlike the SHARE S20 which only drifts horizontally. After this step, I will remap the data in SHARE Cloud Studio to check how well the software can close the loop. And now, here is the Manifold Tech Pocket 2. The Pocket 2 doesn't use a magnetic phone mount, so attaching the phone to the scanner can be a bit tricky. But the phone mount on the Pocket 2 is actually much better than the one on the FJD Tran P2. That mount is the most difficult to attach and remove the phone from. When scanning with the Pocket 2, I prefer using the perspective view. It gives a much clearer look at the scan data compared to the FPV mode, which doesn't allow zooming in or out. In my first review of the Pocket 2, the results weren't very good. Later I found out that the accuracy mode was turned off by default during point cloud remapping. The default setting was speed mode. But this is a measuring tool. Accuracy should never be sacrificed for speed. Why would anyone decide it that way? The perspective view on the Pocket 2 displays a higher resolution point cloud compared to the SHARE scanner. The Pocket 2 feels relatively fast and responsive on par with other competitors. However, its FPV view could definitely use some improvement. You can clearly see that the point cloud resolution on the Pocket 2's preview screen looks better than on the SHARE scanners. Now I'm looping back to the starting point. Let's see how much drift shows up. I can see the Pocket 2 drifting horizontally, and when I turn the wheel, there is a small vertical drift as well, much less than the SHARE C1. Though not as good as the SHARE S20. Next, I will remap the data in my Cloud Studio to check if it can successfully close the loop this time. For the SHARE S20, I will remap without using RTK, since here I'm testing the performance of the slam loop closure. And here are the settings I'm using for the SHARE C1. Both the SHARE S20 and the SHARE C1 took about 33 minutes to process the scan data. For the Pocket 2, I will enable the bundle adjustment option and set the resolution to 0 instead of 2mm. This configuration gives the highest accuracy when remapping. In fact, this setting shouldn't even be available for a user to adjust. Allowing an option to produce inaccurate measurement is unacceptable in professional use. And here is the scanning result from the SHARE S20. Looking at the start and end points, the SLAM algorithm successfully remapped the data. There is no visible gap and no ghosting. I will capture a snapshot of this view for comparison. Now let's check the accuracy. Keep in mind this is one large single loop, so the error will be greater than with smaller loops. Here we measure a 45mm error over a 30 meters for 560-meter loop. And I will capture this side of the wall for comparison. And here is the result from the SHARE C1. When checking the start and end points, the SLAM loop closed successfully, no gaps, no ghosting, and the load surface is level. I captured this view for comparison. Checking the accuracy, I can read a 47mm error over a 560-meter loop, very similar to the SHARE S20. When I test this same spot in the first review, the loop was only 90 meters long and the accuracy was much higher, only 3mm of the error for the SHARE S20 and 9mm for the SHARE C1. And finally, the Manifold Tech Pocket 2. This time it successfully closed the loop. No gaps, no ghosting, and I can clearly see that the lettering on the signage is sharp. I will capture this view for comparison. For the accuracy error, the Pocket 2 performed very well this time, only 32mm, which is even lower than the SHARE S20. Unfortunately, the device prioritized processing speed over accuracy. If that hadn't been the case, my first review test would have produced much better results. In fact, this scan processed in only 12 minutes using the highest accuracy setting, already twice as fast as the SHARE scanner. Let's compare the color point cloud results. The Pocket 2 produced the sharpest text on the signage, slightly better than the SHARE S20 and noticeably better than the SHARE C1. Surprisingly, the 2-megapixel camera on the Pocket 2 outperforms the 16-megapixel camera on the SHARE S20. I really don't understand why Manifold Tech set low resolution as the default in their software. Let's move to this wall. This time the SHARE S20 delivers the best result. It shows more details in the darker plantation area, while the Pocket 2 renders it in a darker tone. Both the SHARE S20 and Pocket 2 capture good resolution on the lower section, whereas the SHARE C1 produces a blur image. The SHARE C1 and S20 show similar color tones, while the Pocket 2 renders a noticeably darker tone and its point cloud isn't distributed evenly. Finally, the tracking performance. The SHARE S20 performs best in this test with no vertical drift at all. This allows it to maintain good accuracy even on a short trajectory without needing to close the loop. The next best is the Pocket 2, which shows slight vertical drift. Still, all three scanners successfully correct their errors during remapping, and the Pocket 2 ultimately delivers the most accurate result. Here is my short review of the three LiDAR scanners. The Pocket 2 produced a very good result in this test, but it still needs more trial before I would consider deploying it on a commission project. The SHARE S20 and S20 on the other hand, I have tested extensively and they have proven to be reliable scanners. None of these manufacturers paid me to make this video, and Manifold Tech didn't ask me to retest that scanner. The Pocket 2 is a loaner sample and I'll be returning it soon. Thanks you guys for watching. I'll see you in the next video.